Hello guys, this is the part 2 of grade 12 calculus, section number 2, differentiation from first principle. So from our last video, um, gradient of a curve y is equals to f of x at x is equals to a can be determined using this formula. Um, Now we can use this formula to determine an expression or a function or a tangent function that describes the gradient of the graph or gradient of the tangent to the graph at any point x. Yeah, let's just say at any point x. Uh, Now, um, what does this mean? Um, this is just this is called derivative. This is called a derivative. Derivative of x, of f, of x. So yeah, it can be g of x, k of x, y, and yeah, it can be anything. So, but before we do the examples, because of this is not it's just a short section. So I think we need to understand the notations, some of the notations. For example, let's f of x, which is equals to y, which is equals to d of y over d of x, which is equals to d of f over d of x, which is equals to d over d of x, and the function, which is f of x, this case, um, which is equals to d f of x, which is equals to dxy. All of these things mean the same thing. Sorry. Uh, these mean okay, all mean the same thing. They all mean the same thing. So yeah, and another thing that you need to note is that d of y over d of x is not equals to d of y divided by d of x. Something that you need to note. So now we're gonna do examples. Okay, let's continue with our first example, which we are asked to get a derivative from first principle. So if you still remember the our derivative formula, just something like this: when h goes to 0 of g of x plus h minus g of x over h. So okay, number one, let's get our g of x plus h is just equals to 2x plus h. You just put x plus h into this x minus 3, then which is gonna be 2x plus 2h minus 3. Then number two, your g of x, you are given, which is just 2x minus 3. Then put everything together, then your g of x is gonna be a limit when h goes to 0 of 2x plus 2h minus 3 minus, very important to put the brackets, 2x minus 3 all over h. Then we're gonna have a limit when h goes to 0, which is gonna be 2x minus 2x minus 3 plus 3, which you're gonna have 2h over h, which is going to just gonna be a limit when h goes to 0 of 2. And remember, a limit of a constant is just a constant, which this thing is going to be 2. So now I just wanna say something. So now you have something. You have this thing, g of x is equals to 2. This is a derivative of g of x. Remember, this thing, it is an expression or a function or a gradient function that describes the gradient of the graph at any point. So this thing means that the gradient of our graph, what is our graph? Our graph is g of x. The gradient of our graph at any point, it is equals to 2, which if you draw a graph, you will see that this will make sense. Let's draw a graph and see. So our graph is g of x is equals to what? Is equals to 2x minus 3. So I think intercept is going to be minus 3 and it's going to be, I think, 3 over 2 and minus 3. So your graph is going to be something like this, which is a straight line. If you can check y, x, if you can check, this thing is a straight line. The gradient is the same, which means whatever you got here is correct. Your gradient is 2. And remember, straight line formula is just mx plus c. Gradient is m. So your gradient is 2. Therefore, we are correct. Okay, guys, let's continue with example number 2. Find the derivative of f of x is equals to 4x to the power of 3 from first principle. The number b will be calculate this and interpret the answer. So we have f of x is equals to 4x to the power of 3, right? Then from first principle, we know that f prime x is equals to a limit when h goes to 0 of a f of x plus h minus f of x all over h. Then f of x plus h is going to be 4x plus h all to the power of 3, which is going to have 4 x squared plus 2hx, I believe, plus h squared and multiply by x plus h, which you're gonna have 4 x cube plus 3x squared h plus 3x h squared plus h cube, which I believe. Then, yeah, which this thing is going to be 4x plus 12x squared h plus 12x h squared plus 4h3. Then your f of x is given, which is going to be 4x cubed. Then let's continue. Our f prime x will be, which will continue from here, which will be a limit when h goes to 0 of a 4x3 plus 12x squared h plus 12x squared plus 4h cubed minus 4x3 over h, which we are going to have a limit when h goes to 0 of a 12x squared h plus 12x h squared plus 4h cube over h, which we're gonna have a limit when h goes to 0. H gonna cancel h, which we're gonna have 12x squared plus 12xh plus 4h squared, which our answer is going to be, when you just substitute h is equals to 0 at h, you just substitute 0 at h, then you're going to have 12x squared. Then what does it mean? It means your derivative of f is 12x squared. Remember, guys, our f of x is equals to 4x cubed. Okay, let me just put this one with black and this one with red, because I want to draw the functions. So we have a function. Let's just start with a, no, I want to draw this one. I want to draw, let's just say we have another function, g of x, which is equals to x cubed. Just want to see something, which I believe is going to be something like this. Then this one would be the one with the red. F will be something like this. This is F. Then this one is G. So f of x is this. Then the gradient formula, or an expression that describes a, a gradient to a curve is given by this function. So what does this mean? It means if you can check your graph, your f, like at any point, you see, at any point, the gradient is changing. That's why we have like a function of x, meaning like with any x we have uh, a different gradient. That's what this unit means. So if we continue to our number b, which they say we should find 0.5 and explain it and interpret it. So our f 0.5, which is equals to our f 1/2, which we just substitute your 1/2 here. It's going to be 12 1/2 squared, which is going to be 12 times 1/4, which is just going to be 3. This thing, it means at x is equals to 0.5 or 1/2, our gradient is 3. That's what it means on this f of x graph. That's what it means. So when you interpret it, you can say a derivative of f of x at x is equals to 1/2 is 3. Or you can just say gradient of the function f at x is equals to 0.5 is 3. Or you can just say the gradient of a tangent to f of x at x is equals to 0.5 is equal to 3. That's our interpretation. So let's do last example, then yeah, we are done with this section, because the most important thing is for you to be able to do a derivative using a first principle, then interpret the results, which I believe that you know what your derivative means. When we talk about graphs and stuff, mostly it will be all about the slope. So yeah, let's get on to number 3. So guys, let's continue for our example number 3, which will be our last example, which it says differentiate g of x is equals to 1/4 from first principle and interpret the answer. We are given g of x, which we need to differentiate using first principle. G of x, which is equals to the limit when h goes to 0 of g of x plus h minus g of x over h. So number 1, g of x plus h it's just gonna be 1 over 4. Number 2, g of x is just gonna be what? 1 over 4. Then put your things together. G of x is equals to a limit when h goes to 0 of 1 over 4 minus 1 over 4 over h, which is just going to be a limit when h goes to 0 of 0. Remember, 0 is just a constant. A limit of a constant is a constant, which is just going to be 0. Which makes sense. Let's just draw a graph, then you'll see. This is our graph. Sorry. Let's just say this is our graph. Okay. This is your y, this is your x. Then when you draw your g of x, because of it's just 1 over 4 at any point of x, it's just this. If you can check, this thing is is horizontal, so it's constant. So there's no increase, there's no decrease, therefore there's no slope. That is why our derivative gets 0. This 0 means at any point of x, our slope is constant, which is 0. So it's not changing. It's horizontal. That's what it means. That's the interpretation. So guys, another thing that you need to be aware of is that the derivative of a constant is 0. So because of there's no slope there, there's no gradient there when we talk about the graphs. So there's a important thing that we need to note. If you can check all of our examples, they said we should differentiate from the first principle. So our next section will be rules for differentiation, which is just a shortcut to a first principle. Because our first principle is long, therefore it's easy to make mistakes. So yeah, now we are going to the third section, which will be rules for differentiation. Okay, guys, let's continue. Section number 3, rules for differentiation. First principle is long, therefore it is easy to make a mistake. That's why we have rules for differentiation so that we can derive mm, like we can derive easily compared to first principle, because first principle is very long. So our first rule says that, let's just say our y is equals to x to the power of n. So our first rule says uh, differentiation of x of n, which is the same as y prime, which is the same as differentiation of y in terms of x, which is the same as dxy, which is the same as dyx, uh, is equals to n x to the power of n minus 1. And where n is element of real numbers, except n is not equals to 0. So this statement just means n can be any number, but not 0. So that is our first rule. E.g., let's just say you have a y is equals to 4 to the power of x 3. Therefore, your y prime is just gonna be, remember you have, okay, we'll deal with this one. Let's remove the constant form. Let's just remain with x to the power of 3. So it will just be 3, which is your n, x to the power of n minus 1, which is just gonna be 3x squared. Then our second rule, which we know, let's just say k is constant. And we have y is equals to k, then our y prime is just gonna be 0. We know this one. We know that a derivative of any constant is 0. So let's do number 3. Number 3, let's just say you have a y is equals to a k, f of x. So your d of like your derivative of y in terms of x is just gonna be k, then derivative of what? F of x. E.g. is just, let's just say you have 4x to the power of 3, which is equal to y. Then your y prime is just gonna be a let's just say d over d of x of everything, 4x to the power of 3, which you just take your constant away, then you derive this thing, which it takes you back to rule number 1, which you're gonna have 4 into a 3x squared, which is just gonna be 12x squared. Then let's go to number 4 and number 5, which I'll just combine them. So if you have, let's just say you have y is equals to f of x plus or minus g of x. And then your y prime is just gonna be d over d of x, because you are deriving in terms of x. It's gonna be plus or minus g of x. Then this thing, you're just gonna say d over d of x, f of x plus minus d over d of x, g of x. Yeah. Then yeah, let's just do an example with this one. Let's just say we have a y is equals to let me just think, is equals to 3x squared plus x to the power of 4. Then your y is just gonna be d over d of x, yeah, y prime, sorry, 3x squared. Okay, let me just do step by step, plus x to the power of 4, which is just gonna be d over d of x, 3x squared plus d over d of x, x to the power of 4, which will take you back to rule number 2 and rule number 1. You can take constant out. Then when you derive this one, I mean x squared, you're gonna have 2x. Then this one just gonna be 4x to the power of 3. Then your answer is just gonna be 6x plus 4x to the power of 3. Then yeah, let's just do one last example, then we are done with this section number 2 and section number 3. Yeah, guys, this is just a small summary of our rules. If y is equals to x to the power of n, our derivative will be in this form. If we have a constant and we derive a constant, we're just gonna get 0. Like, constant doesn't change, so we do not have a slope gradient. If we have a function times a constant, so your derivative will just be a constant times the derivative of the function. And if you have two functions, then your derivative will be, if you have a, yeah, sum of two functions, the derivative is just going to be sum of those two derivative functions. Yeah, if you get what I mean. Yeah. So let's just do this example, then we're done with this video. Imagine deriving this curve using a first principle. So it's gonna be very long, and you'll end up making mistake and losing some marks. So yeah, let's just derive using the rules for differentiation. So yeah, you can, but when I have like this kind of a function or a curve or a formula, the first step is to simplify and start to derive. So let's just simplify and see what we can do. So your k of t is just gonna be t plus 2 all squared and t plus 2 over square root of t. So is this thing just gonna be t squared plus 4t, I believe, plus 4, so, and t plus 2 over square root of t, which just gonna be t to the power of 3 plus plus let me see, plus I have 4t squared plus 2t squared, which is going to be 6t squared plus you're gonna have 40 times 2 is gonna be 8t plus 40, so it's gonna be 12t plus 8. 4 times 2 is just gonna be 8 over square root of t. So guys, remember if you have, let's just say you have a plus b over c, which is just a simple algebra, you're gonna have a over c plus b over c. So when we carry on with this one, we're just gonna have t to the power of 3 over t to the power of 1 over 2. Remember, square root of x is just gonna be x to the power of 1 over 2. That's why we have t to the power of 1 over 2. So now you're gonna have plus 6 to the power of t squared over t to the power of 1 over 2 plus 12 to the power, 12t over t to the power of 1 over 2 plus 8 over t to the power of 1 over 2. And another thing that we need to know, when you have, let's just say you have x squared over x, you end up with x. Why? Because of this thing, x squared over x is the same as x2 minus 1. Because of this, the denominator x to the power of 1. So you're going to have x to the power of 2 minus 1. Then you're going to have x. So if you have t to the power of 8 over t to the power of 3 over 2, you're going to have t to the power of 8 minus 3 over 2. When this thing goes up, it becomes minus. Then when minus goes down, it becomes what? Plus. So yeah, let's carry on. So that means here you're going to have t to the power of 3 minus 1 over 2 plus 6t to the power of 2 minus 1 over 2 plus 12t 1 minus 1 over 2 plus 8t negative 1 over 2. Because of we don't have t, so you just take that t, sorry, yeah, because you don't have t in the numerator, so you just take that thing, then it becomes t to the power of negative 1 over 2. Therefore, then you do your thing, which here is going to be 6 over 2 minus 1 over 2, just going to be t to the power of 5 over 2 plus 6t, which is going to be 4 over 2 1 over 3 over 2 plus which this one is going to be 12t 1 minus half, just going to be half plus 8. Yeah, this one doesn't change, minus 1 over 2. Yeah, which I believe I did correctly. Remember, you still have k, t. Then now you differentiate your thing. Therefore, k of t is just gonna be remember, use the rules for differentiation. See now we have here you have a function multiplied by constant. Then here you just have that x to the power of n. Then you have addition, addition, you have addition, addition, like all the rules that we did are here. Then you're just gonna have a 5 over 2 t. Then 5 over 2 minus 1 just gonna be 3 over 2. Then plus 6 multiplied by 3 over 2 t, 3 over 2 minus 1 is going to be 1 over 2 plus 12 multiplied by 1 over 2. T half minus 1 just going to be negative half. Then this one is going to be plus 8 multiplied. Don't forget the negative sign, negative 1 over 2. T, then negative 1 over 2 minus 1 is going to be negative 3 over 2. Then you simplify your thing. You're going to have 5 over 2 t, 3 over 2. Then this one is going to be 3 times 3, which is going to be 9 t, 1 over 2. And this one's going to be plus 6 t, negative 1 over 2. Then this one's going to be negative 4, which I believe is going to be negative 4. Negative 4 t to the power of negative 3 over 2. Then, yeah, then you are done. This is your answer. This is your answer. This is your answer. Or you can just carry on if you're still comfortable with it. Want to simplify? You're going to have 5 t 3 over 2 all over 2 plus 9 t 1 over 2, which, yeah, plus 6 over t 1 over 2 minus 4 over t 3 over 2, which I believe is your answer. So guys, there are two things that you need to note. You use rules for differentiation if question doesn't specify how you must determine the derivative. And you use first principle if question specifies so. So yeah, guys, that's the end of our video. So we're gonna do on our next video, I believe we're gonna do second derivative, which is just the derivative of the first derivative. So yeah, but we need to understand what it means to functions, to graph and stuff. So that's the end of our video.